This is part 2 of a 2-part tutorial series on how to create custom golf gang courses. This video will deal with a few more advanced options, as well as the visual scripting utilized in the workshop. This tutorial is not intended to teach you everything you need to know about the visual scripting, but should give you a good foundation to begin using the scripting. You need no programming experience to do this. The Golf Gang developers have provided us an incredible sample scene we can use to learn more about customizing our created courses. This course is located in the Golf Gang Workshop folder, the workshop, and then the course scene file. If this window appears, you may need to import TMP essentials using these buttons to help the text appear in the sample holes. There are 9 holes in this scene, each explaining a different topic. As you begin wanting to get more advanced in your course creating, I recommend going through each of the holes in this scene one at a time in Unity's play mode to discover what each of the holes is teaching you. You can switch back to scene view as you play the holes to explore what the text is describing, and can experiment with it. In this video, I will go into some detail on the options explained in some of these holes. On hole 8, we learn about checkpoints. If you want to learn about checkpoints, simply disable all other holes, enable only hole 8, and press play. Typically, players will only respawn after falling off the course if they were able to come to a complete stop. Placing a checkpoint will give the player a place to respawn even if they weren't able to stop completely, like so. I would make a prefab of this object you can use later by dragging it into your project file. Additionally, you may not want players to be able to respawn on every surface. If there is a part of your level that you don't want players respawning on, simply change its layer to Environment No Spawn. A player will no longer be able to respawn on this part of the course, even if they come to a complete stop. Now I want to focus on hole 2 to begin learning about the visual scripting. First off, if you want to get serious with some visual scripting, we should add one more add-on. Go to Tools, Bolt, Unit Options Wizard, plus, then bolts.addons.community.runtime. Click through this menu to get it all added. Now, let's look at this moving gate object in hole 2. In play mode, we can see it's moving up and down. This is accomplished using visual scripting. If I press Escape, go back into scene mode, select the moving gate, and press Edit Graph in this Flow Machine component, I can see the visual scripting used to accomplish this movement. At first glance, it looks complicated, and it is complicated, though it will make more sense once we understand what each of these nodes do. You may not understand this all completely. Luckily, we can get by to start with by just using the visual scripting graphs the developer have made for us. You don't need to make this from scratch if you don't want to. You can navigate these graphs using the mouse scroll wheel to zoom and middle click and drag to move. Each one of these boxes are technically called units. This first start unit sends a signal to the flow input of the timer unit to start this timer when the hole starts, and its duration is set to 5 seconds. You can see the completed flow output of the timer also feeds into the start flow input, effectively creating an infinite loop, looping every 5 seconds. If we follow the tick flow output and the elapsed percent value output, we can say they go into this animation curve evaluate unit. This unit utilizes a curve to make a smooth variable output. You can see here the developers have put an animation curve unit that feeds into this input here. This time input uses this value from the timer loop, and ultimately this output sends a value that loops between 0 and 100, as you can see here. Now let's look at the top part of this graph. This self unit will output the object this flow graph is attached to, in this case, the moving gate. That is fed into this getTransform unit, which then pulls the transform values from this object. In this case, we don't care about the scale or the rotation. We just care about the position. So we use this unit to get the position of the object. It outputs the x, y, and z vector. This unit then splits the x, y, and z into each their own output. This unit here creates a new vector out of the inputs from the top part of the graph and the bottom. Because we want the left-right and the forward-backward position of the wall to stay constant, the x and the z from the object's existing position are used in the vector. Because we want the object to move up and down, we will use the output from the animation curve for the y of this new vector. You'll notice that the tick from the timer unit flows through this whole graph. This is necessary to make sure this all updates every rendered frame of the hole you play. Our final unit is the set position unit. This unit takes this new vector we've made and sets the object's position to these new values, effectively keeping the x and the z values constant, but varying the y with the animation curve, creating this up and down movement. Again, it is not vital to understand everything I've gone over here. What we do need to know how to do is modify this graph to fit our own custom courses. The first thing that is easy to modify with this moving wall is the duration of the timer. Right now, it completes a loop every 5 seconds. If I changed this to 2 seconds, this wall moves faster. And if I changed it to 10 seconds, this wall would move much slower. You'll notice that as I change the flow graph here, it changes the movement of the original moving gate as well. That is because the gate flow graph is not attached to this object, but is an asset by itself. If I don't want to modify the original flow graph, I'm going to need to navigate to the workshop folder again, the flow macros folder, and then I should duplicate this gate flow macro by selecting it and pressing Ctrl D. Now I can attach this new flow graph to my new object, and I won't be modifying the original flow graph. The second thing I might change is this animation curve. By double-clicking on the curve unit, I can edit the animation curve. These curves work utilizing keys on the graph. You can right-click to either add a key or delete a key. I can change the behavior of this moving gate by moving these keys as well. I can increase the height to make it move more, or I can decrease the height to make it move less, like so. I can add, delete, and move these keys all around like I'm doing to get more specific and unique behaviors out of this animation curve. To avoid the object really jumping around, I would avoid moving the first or the last keys. A third way I can modify this is I could change it to, instead of moving up and down, it moves left and right. This can be done by simply changing the output of the curve to go into the z instead of the y, then using the original y to keep that y variable constant. A fourth way I could modify it is using ProBuilder. Again, I recommend watching other tutorials online to become proficient with ProBuilder. You can drag this wall into your assets folder to create a prefab you can use in any other course you're making. Just be sure to make a new graph before you modify it too much, or you'll be changing the behavior of much more than you intend. It is also very simple to attach a flow graph that the developers created or that you have modified to a new object. Simply add a flow machine component to the object, and then click and drag the flow graph into this space here. There are 7 more holes that we have yet to cover, most containing examples of other flow graphs. Some get fairly complex, and I encourage you to look at them and find what variables you can change to get the results you want. For example, this graph makes you bounce. By changing this multiply unit in the graph, you can increase or decrease the bounce. There are also flow graph examples you can use to change object colors, give you speed boosts, give you springs to jump on, and much more. One last thing I will bring to your attention is the existence of super units created for us by the developers. You can think of these as flow graphs within flow graphs that are intended to achieve more complex tasks without cluttering up our main flow graphs space. If you look at the levels already being created by golf game course creators, you can begin to get a full idea of the range of possibilities of this visual scripting system. and it can get very complicated and nuanced. Luckily, we can also make very creative and unique levels without having to make our own flow graphs at all, and we can just utilize or modify the flow graphs in the example scenes that we already have. If you want a community to ask more questions to, I would join the Discord community of creators. The link to the Discord is in the description of this video, and there are many community members willing to help, and it provides a place you can show off your workshop creations. I hope you found these tutorials helpful, and good luck creating.